Hello everybody, my name is Adriana Ticonwi Sanchez and I am Yamilet Gardano Rivera. In this video we show you what is a differential equation and how to identify and solve the separable equations. Okay, let's start.
We are going to start what is a differential equation. It's an equation that relates to a function, its derivatives and its variables. Usually we represent a function like f of the variable that you want. You can put any word. The derivative of this will represent it as first f of the variable, and the variable, which in this case is the seed. You can also write the function with another word, and its derivative in this case is first apple, but this type of annotation respects the same variable that we use. Solving a differential equation means finding the function or functions that satisfy the equality. Differential equations are used, for example, to find out how many people will be in a place after a certain time. Another application is the transmission of heat. We can find that amount of heat is at a certain point of the rod.
Now, I will explain when a differential equation is separable. We will see in the following example by saying that if they are separable or not. I mean when we pass from one side all the terms of x and the other terms of y. We have a differential equation n equal to a function in terms of two variables. We separate this function as a product of function in such a way that one of the function depends only on x and another only on y. Once we have it factored, in that way we can separate the h of y by dividing and the ex by multiplying. And then it remains die between h of y and g of x for dx. Is to know how to factor a function that depends on x and y in a product of function. That one depends only on x and one only of y. To factor it we are going to follow three simple steps. Step number 1 is to find two values such that when substitute in the function the result is different from 0. The second step is to calculate f from x0 y and f from x y0. The third step is to check if the product we calculate previously is the same as multiply the initial function by the value we obtained before. To make it clearer, I'll show you an example so you know what I mean by this. We have the following equation, which is very complicated and we don't know how to factor it. Then let's see, the first step is that the function is replaced by a value whose result is different from 0. The function that we want to fulfill this role is this. As we see if we substitute 1 and 1 in the function, we see that it results in 2 making the respective operations, and as we notice, 2 is different from 0. Now let's calculate f from x0y by f from xy0, and since we know that x0 is 1, y0 is 1, we can calculate these terms. Here I mean that x is worth 1 and y won't change. Within the function we will change to x for 1 y. We will later it as s, then will be 1. Then will be 1 squared plus 1 squared y squared, that f of 1 y. That we have to multiply it by f of x, 1. Now let's leave the x unchanged and replace y with 1, and it will be like x squared plus x squared 1 squared. We do the operation and it will be like shorted 1 plus y squared for 2x squared. Going to step number 3, we must check that f of x0, y0 by f of xy. is equal to the multiplication of f of x0 y and f of x y0. We know that f of x0 y0 is 2 and that the f of xy is the original function. For this we are going to reorganize the two sides of the equation and it will be this way. 2 for the original function, that is x squared plus x squared y, x squared is equal to the result we had obtained. Reflecting the new equation, we have that this 2 is multiplying past dividing. And as we can see, it's exactly the same original equation. We verify that it's separable, and moreover we already have its factorization by means of the steps. We conclude that this procedure helps us for two things. One is to determine if the equation is separable, and the other the factor the function. To solve the differential equation, we start by spending all terms of x one side and all terms of y the other hand, in this way. Now that we have that expression, we can begin to integrate the equation, which apparently is quite easy to integrate. We can observe that the integral left side is the integral known called arctangent, and the integral right side is the easiest way to integrate, which will be as x cubed on 3. Reflecting, y we passes arctangent, the other hand as tangent. In this way, we have 2y equals tangent of x cubed on 3 plus a constant integrate. Well, now we found the function that satisfies the differential equation.
In the first function, x is equal to 0 and we substitute in the original equation and we simplify. That is equality to y squared plus 1 and we'll do the same with the variable y. The new function is equal to y squared plus 1 for x squared plus 1. We pass the terms of y from one side of the equation and the terms of x from another side. How y squared plus are multiplying past dividing and the x past dividing too. After that we integrate. The first side of the equation is a well-known integral. That's arctangent of y is equal to x cubed over 3 plus c. After that we simplify y and this is the function that satisfies the equation. We finished. That was all for today. Thank you.